So this is our pre-assembled prototype for our thesis. It's the Mung analyzer, or the plant growth analyzer. It uses a Raspberry Pi version 2 camera and uses a Raspberry Pi version 3 for the actual board, and as well as a touchscreen for the display. Our box setup for the enclosure or the dark room for taking the images and having the plant in the dark area is over here. So we can see here that it opens similar to a cabinet and has the plant in inside, and it has a black material or a black cover to make sure that once the image acquisition begins, the actual area is dark. This is done so to avoid any other green pixels or any other green levels in the image, as well as to avoid any unnecessary edges in the canny edge filtering. So this isn't the final area yet. We're still going to properly stick the black material to the sides of the enclosure to ensure that no other edges will be detected during the canny edge process. So this is our prototype working right now. It's using a Raspbian operating system, and the code for the actual GUI is mostly based on Python programming language. So here I'm going to run it. The Mung analyzer, or the plant analyzer. Generically, it's supposed to be a plant analyzer, but since we're restricting our study to Mung bean, we decided to name our GUI the Mung Bean Growth Analyzer. So here you can see the GUI. So for the operation of our prototype, for image acquisition, the camera is supposed to be placed within this slit here, over here, to capture the images. So there's an internal lighting inside the enclosure for the lighting of the plant, and then the results will be shown here after pressing the record latest result. The results of the analysis will be shown over here, where the green pixel area is 17 and the height is 8. So this should be converted into centimeters. So the output can be seen over here, where this is the image of the plant, and then this is the canny edge processed image of the plant. So it detects the length of the stalk as well as the green area of the leaves. Now, after the image acquisition, it's actually sent into the Google Drive folder, and actually if it's connected to a network, this Google Drive folder will sync to our Gmail account so that it can be processed remotely via MATLAB or any other processing tools. It won't be demonstrated, but this would be our enclosure used for the soil analysis test. But right now is not the time for the soil analysis test scheduled, so we won't have the time to demonstrate that. But it's a pretty straightforward process, similar to what we did to this plant enclosure. In this video, we can say that we were able to do the specific objectives of the study, which in particular are: number one, decide an enclosure scheme or a darkroom scheme for the image processing, and number two, create a prototype for the image acquisition as well as the image processing algorithms, and number three, to design a software or a program that would be able to acquire the images as well as record the results. So we can see here that this is for image syncing, or forcibly syncing the images in the Google Drive, and this is for our control groups, and this is to choose whether it's a plant or soil analysis. And for the soil test, we simply have to click these tests to see the results of the rapid test soil test kit